In this video, we're going to be looking at a couple of questions typical types of questions you might see on an assignment or a quiz with regards to theoretical and experimental probability. And we're hoping to tackle in this video comparing theoretical probability and experimental results, expressing a probability as fraction, decimal, a percent, or in words, and determining the probability of an event. Okay, so this first question here kind of tackles the idea of experimental and theoretical probability. If heads is flipped on a coin 3 times in a row, what is the probability of flipping a tails in the next coin toss? So my question is, we tossed a coin 3 times in a row. Does that have any bearing at all in what will come up next? If it's a fair coin, then no, it shouldn't. And so we can calculate using theoretical probabilities the probability of flipping a tail in the next coin toss. For any coin, there's 2 possibilities. Either you flip a heads or you flip a tails. So there's really only 2 possibilities. So that means the probability, regardless of how many times one may have shown up for any option, so the probability of tails for any one of our coin tosses, even for the first 3 of which we didn't get a tails, is going to be 1 tails out of the 2 total possibilities. Or in other words, 0.5 if we divide 1 by 2, and 0.5 times 100 units percent gives us a 50% probability of flipping a tails in the next coin toss. Again, this brings up the question of theoretical versus experimental probability. Every time you flip a coin, the probability is going to be 1 out of 2. That's a theoretical probability. If we were to flip our coin multiple times, we aren't going to see that every other coin toss is going to be heads, then tails, alternating. Heads, tails, heads, tails, heads, tails. We could get 3 heads in a row. We could get 5 heads in a row. We could get 10 heads in a row. But eventually, if we do enough trials, enough flips of our coin, we're going to see that the number of heads and the number of tails should be roughly half of the number of tosses each. And the more tosses we do, the better the results will, or the more likely our results will look like a 50% split. But again, it doesn't matter what we flipped the first 3 times. The probability of flipping a tails in the next coin toss is still going to be 1 out of 2, or 0.5, or 50%. And in this question, we're asked to order the contest results from greatest to least chance of success. So right now we have 1 outcome out of 6 tries, 2 winning outcomes out of 14 tries, 3 winning outcomes out of 15 tries, and 4 winning outcomes out of 25 tries. The best way to determine which has the greatest and which has the least chance of success is to turn these into decimal representations of the probabilities, because they're more easily comparable. So I have 1 winning outcome out of 6 possibilities. I do that on my calculator. I'm going to get a decimal value of 0.16 repeating. For the second one, I've got 2 winning outcomes. I'm going to move that over here. I've got 2 winning outcomes out of 14 trials. If I do that on my calculator, I'm going to get 2 divided by 14 equals 0.14, and a lot of other numbers, but I'll throw in a couple more. 0.142857, and it keeps going. In fact, it should repeat that full sequence, 0.142857. 3 out of 15 I'm going to do here. I have 3 winning outcomes out of 15 possibilities. I do that on my calculator, and I'm going to get 0.2. No repeating, it's a terminating decimal. Lastly, for 4 out of 25 tries, I do on my calculator, I'm going to calculate 4 divided by 25. And that works out to exactly 0.16. Again, not terminating, or sorry, not repeating, but terminating, 0.16. So a bit different from the first one, which is 0.16 repeating. So I'll list them again. A, the probability is 0.16 repeating, which is approximately 0.1667. For B, I've got 0.142857. For C, I've got 0.2. And for D, I've got 0.16. So, which is the least successful? Well, that would be 0.14287. So this is least successful. Which is greatest? That would be C. This is greatest here. So between 0.16 repeating and 0.16 terminating, which is the higher number? Well, 0.16 repeating is 0.1667 approximately. And 0.16, well, that's exactly the same as 0.1600. So we can see that 0.16 repeating is actually the larger, the greater number. So this would be second greatest, which means that 4 out of 25 is going to be second least. So if we wanted to order our contest from greatest to least, our order would be C, then A, then we'll go with D, and lastly, B are our options. So once again, to summarize, theoretical probability is a calculated ratio of successful outcomes to total outcomes. So that's something we do on paper. Experimental probability is if we were to actually perform trials and come up with actual physical values. So it's also a ratio, but it's of successful outcomes to total outcomes, or in other words, it is a probability, but it is determined by actual trials and experiment.